Okay, problem 1, quiz 2, application of Newton's laws. An Atwood machine is set up by suspending two blocks connected by a string of negligible mass over a pulley, as shown in the figure above. The pulley has negligible mass, but there is friction and it rotates. The system is released from rest, and after 1 second, the speed of 3 kg block is 1.8 meters per second. Which of the following is the best estimate of the external frictional force acting on the two-block system? And here are our options, A, B, C, D. Okay, so how do we start? First of all, you're already familiar with this kind of problems. So, as if there were no friction, what would be the acceleration of the system? How would you solve that for the acceleration of the system? Okay, there are two ways, the hard way and the easy way, as you remember from the previous videos and previous quiz. Please look at quiz 1. So I want to have an easy way, so I define this whole thing as a system. So I define both masses as a whole system, of course, including the pulley and the thread. So the total mass of the system is 3 plus 2 is 5 kilograms multiplied by the acceleration of this whole system equals the net force. The external net force, as if there were no friction, would be just the force of gravity, right? Which is the difference between these two masses multiplied by g. So, and it would give me acceleration of the system 10 divided by 5 would be 2 meters per second squared. However, the actual acceleration, and I can see that 1.8 meters per second squared is the acceleration because that is the speed after 1 second when it was released from rest, which is the acceleration So my actual acceleration is 1.8, which is less, and it makes sense because the force of friction in the pulley is the other force outside net force, right? That is acting on these two masses. Okay, so actually, yeah, so we consider this as an outside force, fine, on the pulley. Okay, on the two masses and the pulley and the net, so that's our system, but the friction from the is outside force as well as the gravity. Okay, so it reduces the acceleration. So by how much is the acceleration reduced? By how much? It's by a 0.2, right? 2 minus 1.8 is going to 0.2. So for the 0.2 meters per second squared, right? That's my acceleration that is due to the friction force. That's the acceleration that is due to the friction force multiplied by the mass of the system, which is 5, right, is going to be equal to the net force, which is force of friction, right? That's what we want to find. And it will give us 1. So 1 Newton of force of friction is required to make this to provide for this 0.2 meters per second squared acceleration for the 5 kilogram mass. And that is what we see in the options right there at the bottom. I cannot scroll, I'm sorry, but the answer is 1 Newton. It's the 1 Newton of force, which is the answer C. This is C.